Hello, this video is going to give you an idea about the relationship between a function and its gradient function. Okay, here we have in red color the function mentioned here is the parabola, the simplest parabola, y equal to x square. So this is the curve y equal to x square, the red colored one, and there are some tangents drawn over there at different points on the curve. You can see at this point the tangent is horizontal, which is parallel to the x-axis. Therefore the slope of this line is 0. So at 0, at x is equal to 0, the slope is 0. Right? At the point x is equal to 1, which is 1 comma 1 on the curve, you can see the blue line here, which is the tangent, and the slope of this line would be, say, 1 over half. So this is 1 and this is half, so 1 over half. The slope of this line is 2, which means at x is equal to 1, the slope is 2. Okay, now consider the point x is equal to 2, and this is the point here, and this is the y value 4, and you can see the tangent here, which is blue, and the tangent crosses the x-axis at 1, and the y is 4 over 1. The slope of this line would be 4. Okay, which means at x is equal to 2, the slope is 4. So we have various slopes at different points on the curve. So 0, the slope is 0. At 1, the slope is 2. At 2, the slope is 4. And I can make these points the coordinates on the graph. So 0, it's 0. At 1, it's 2. At 1, it's 2. At 2, it's 4. Okay, so if I plot these points, x values against the slope, you get the line which passes through these 3 points, right? So this is nothing but the gradient function of x square. Okay, we know that the gradient of x square is 2x, right? Dy dx of x square is 2x. Therefore the line which we drew now is nothing but 2x, y equal to 2x. What happens to the other side of the curve, that is on the negative side? We have this point, negative 1 comma 1, right? And you can see the tangent through that point. So at negative 1, the slope is negative 1, right? Because it's on the other side. And at negative 2, you can see that the slope is 4 over 0.5. No, it's 4 over 1. It crosses the x-axis here, and it's a negative slope. Therefore at negative 2, the slope is negative 4. Okay, and the same thing at 3, the slope would be negative 3 and negative 6. Okay, and even if you substitute at 2x, you can see that, sorry, this is 2, negative 2, negative 4, negative 6, and so on at each point, which means that the gradient function should be below the x-axis, right? Therefore if you plot the points for negative 1, the gradient is negative 2. Therefore you should be plotting it here, negative 1, negative 2, and negative 2, negative 4, and you can see that the line continues to be like this. Okay, so this brown line which I'm drawing here is the actual gradient function. Okay, basically speaking, the curve is x square and its gradient is 2x. So at each point of x you will have 2 times the value of x, and that would be the gradient, which means that's the slope of the tangent at that particular point. So you can start drawing the gradient, you can start finding the gradients and mark the points and then join the points. Whatever you get will be the gradient function. In this case it's 2x. Okay, so when you are looking at the positive negative part of this, when the curve is going upwards like this, you can see that the gradient is positive. The gradient function, which is the green line, dotted line here, is on the positive side of the y values, right? It's positive. It's on the upper side of the x-axis. And when the curve is sloping down on this side, that's if the curve is sloping down, which means the tangents would have a negative slope. Therefore, the gradient function will have negative values for its y values here. Okay, so when the curve is sloping down at any place, the slopes would be negative. When the curve is sloping up, the gradient function would have a positive value. The slopes of the tangents would be positive. So this is called a decreasing function because the slopes of the tangents are negative and it's decreasing, as you can see, and this is called an increasing function. So theoretically, a decreasing function will have its gradient function negative and the increasing function will have its gradient function values positive. Now let's try to find out the gradient function of this curve. Okay, so let me start at this point because these 2 points are really interesting. The gradient would be parallel to the x-axis, and obviously the gradients at these points are going to be 0. So therefore at this point, which is somewhere here, we don't have to worry about where it is. At this point the gradient would pass through 0, as well as at this point the gradient is going to pass through 0 on the x-axis. Okay, what happens in between? You can see that this part is an increasing function. So from infinity up to this point, the gradient is going to be positive because you can see that it's increasing. Therefore it's going to be on the upper side of the x-axis. Okay, and it's going to pass here. And after this point, the gradient function is decreasing. Therefore after this point, the gradient function would be here. Okay, so say, just for example, say at this point the gradient looks like it's going to be somewhere around 4, maybe somewhere here, right? At this point the gradient is almost 3 or 4, so maybe here. Therefore the gradient line is going to be coming over like this, reaching the 0 at exactly the point where you have horizontal tangent at this point, and then after this point the gradient starts decreasing and it goes on like this, right? But it's not going to continue forever because at this point it's going to be 0 as well. Okay, so at this point where it starts to turn to the other side, the gradient also starts turning. Okay, you can see that this is like this and the gradient would start reducing, right, to 0. So the gradient function would start decreasing and it would start reaching 0 at this point. So basically the line for the gradient, the curve in this case, would go like this and reach some point here where it actually changes the direction and the gradient would start moving like this, reaches 0, and as you can see this is a positive part. So after this point the gradient starts moving upwards because it's, as you can see, the gradient starts increasing at each point of this function. Okay, so the gradient function would possibly look like the brown curve that I have drawn here. So let's see exactly how the graph software is going to draw the gradient function of this. Yeah, you can see there it's a parabolic curve and it's almost close to what we drew. Hope it's clear how to draw the gradient function from a given function. Okay, start looking at the increasing part of the gradient function, sorry, increasing part of the function. So when the function is increasing, the gradient would be on the positive side. When the function is decreasing, the gradient would be on the negative side. And when the function turns at this points, the gradient would be 0. That means it will pass the x-axis. Okay, so that's how you need to draw the gradient of a function. Can we do the opposite of this? That's gradient function is given. Can you find the function as it is? So this is a line. As you can see, this is a line to y equal to 2x. So let me write it here. Y is equal to 2x. Can we find the function from this? Let's try this out. At 0, the point is 0 comma 0, therefore the gradient, each point on this, each y value of this gives you the corresponding slope of the function at each point on the x values. Say for example, slope at 0 is 0, slope at 1 is 2, slope at 2 is 4, and slope at 3 is 6, and so on. What does it actually mean? Slope at 0 is 0 means at this point the curve is having a tangent horizontal. Okay, again at this point 1 comma 2, the slope is supposed to be 2. Let's take this as our reference line because this has a slope of 2. Okay, therefore at this point the slope is going to be something like this, and at this point the slope is going to be 4, which would be a bit greater than that, and at this point it's going to be much steeper than the previous one, and at this point it's going to be steeper, which is 8 and 10. Right? So as we can see, the curve is going to move upwards slowly. And another important point here is we don't know where the curve actually is. It could be here, or it could be, it's only the slope that the y equal to 2x line says. It doesn't say where exactly the curve is. For example, you can understand what I'm writing here. At 0, the slope is 0. It doesn't mean that it has to pass through 0 comma 0. So at 0 it could have a slope at this point. The curve could have a 0 here, which means the curve would be going at this point or something like this. Okay, or the curve could have crossed the y-axis here, and still if it crosses like this, the curve is still it still has a 0 tangent at this point, 0 slope at this point. So the curve could be anywhere. It could be even here, and still it is 0. It doesn't say, this doesn't say where the curve exactly is. Okay, so if you can see, this is called the slope field. What happens here is, so I just removed all the scribblings there. Now you have something called slope field. So what does it mean? Let me go back to scribbling. You can see that at 0 the slope is 0, it's almost straight line, and oh god, it has come back, and you can see that it follows the strokes that we have done. So at this point the curve could be anywhere. Okay, it could be going anywhere like this, and as you can see, this part is how the slope of the curve would be. So you can see how the curve, say for example, if I start drawing the curve from here, the curve would follow this direction and it would go like this. And if I start drawing the curve from here, the curve would go like this, and it might maybe go like this, or it might be somewhere here. But for this line y equal to 2x, if this was a gradient function of some curve, that curve could be any of these curves, which means that we have something called family of curves. There is no one particular solution for this. Okay, which we can see it on this graph now. See, so this is the line to y equal to 2x. You can see it here, and don't worry about the word here, integral function, that we'll be seeing soon. But you can see that for that line, these are the functions that would actually make the gradient function to be y equal to 2x, because on these functions the value of the slope of the tangents for each x are the same. You can see that for 0 the tangent is the same, has the same slope, and for 1, say for example, you can see the tangents are all the same, so they all have the same slope, which is at this point. So they all have the same point on this gradient function. Okay, so when you are going backwards from gradient function to the function, you don't have one particular solution, you have a family of curves. Okay, so in order to find a particular solution, if you want to find only this curve, then you should know it. You should know at least one point through which it passes. Say for example, you can find this curve if you know that it passes through this point. you can find this curve if you know that it passes through this point. So at least if you are given at least one point through which the curve crosses, then you can actually find the particular curve that you want, which has the gradient function of y equal to 2x in this case. Okay, now let's see if we can find the function whose gradient function is this curve. You can see that this is a parabolic curve, and we need to find what would be the function for which the gradient function would be like this. Okay, that's our task now. So what happens is each point on this curve gives you the gradient of the curve that we are going to find. Okay, so we are actually going to find the various gradients, the slopes of the tangents at every point. So let's say at this point, that's at 0, the slope is supposed to be 1, which means at 0 the slope would be of this, something like this. Okay, so let me draw it clearly. It's supposed to be like this. Okay, now at 0, at this point, the value is 0, which means the slope has a tangent, the tangent has a slope of 0. So the slope should be, the tangent should be something like this. Okay, and we move on. The tangent is actually, the slope is actually decreasing on the negative side or increasing on the negative side. At this point, which is 1, at 1 the slope is -2, which means at this on this line you can see I have already mentioned that it could be anywhere, but let's just draw the slopes on the x-axis so that we can trace them on other places of the graph. So at 1 the slope is -2, which means that it should be something like this. Okay, at 2 the slope is -3, therefore it should be much more steeper than the previous one. Okay, it's hard for us to draw manually, but still it's little more steeper than what we drew for 1. At this point 3, the slope is -2 again, so it's similar to 1. Okay, and then at this point the slope is 0, therefore again the slope needs to be, the tangent has to be horizontal. After this you can see that the slope is becoming positive, so this here it's 1, therefore it should be again positive, and then here it is a little bit more, which is 2, therefore at this corresponding x value here would be little steeper and steeper and steeper. Okay, and it goes on. Now we can't actually draw a curve like this, so we need to move the tangents at various places where we can actually draw the curve. Okay, so here we can see that if we assume that it passes through 0, 0, say maybe the point goes here, but at this point it has to turn because the tangent has to be horizontal here. Okay, so it has to turn, and then this we can make it, so here say for somewhere it has to move here, and then against on this line it has to be something like this. So anywhere wherever it passes, so the tangent should be all the same. So maybe it passes through this point, so that you can actually join this. On this it's again this way, so maybe it goes like this, and then at this point on this vertical line the tangents are going to be horizontal, which means the curve is going to turn. Okay, because it has to be horizontal, so it goes like this. So if you continue, it has to come up to this point so that it can have a tangent like this, and then you can have the slopes like this, so that the curve goes like this, and at this point the tangent is something little bit positive, sloper, and it goes steeper. Okay, therefore the curve should be something of this type. So you can see that it's a cubic curve. We started with a quadratic, a parabolic curve, and then we are getting a cubic curve as its gradient function. So if you look at the negative parts, this is negative and steeper, so it goes higher and higher values here. Okay, it's steeper and steeper here, therefore it's much steeper like this. Okay, let's check this with technology and let's see what the technology draws for us. And here are the curves. So you can see, you can actually see that it's not a particular curve, and we can actually look into this one which is passing through the 0 0, and we are almost correct, but this is more steeper because we can't actually draw a steep line there, steep curve. We cannot draw the correct line with the slope, but we can see that the curve actually goes like this, and it reaches a minimum here and it goes upper and upper here, right? And all these curves are like this. Any curve that you are going to see would be of this type, and it all turns at this same point here and at the same point here, which means at these 2 points the tangents are horizontal. And you can see how the curve becomes steeper and steeper here as the gradient function has more and more values here. Okay, so this is easy. When you are given a function, you can find out the y values, and those y values you should assume them to be the tangents at different places on the curve, so that you can actually make the shape of the curve. And if you are given the points, say you are given 0 0, and you know where the minimum turns and where the maximum turns, then it's easy for you to connect all these points and see which of these various curves fit into your actual definition. Hope this is clear. See you in the next